Hello, today we return to UniswapV3. We discuss its swaps and explore code of swap function and see how it works in code. For start, for beginning I have project in Foundry. I copy final project from Ivan Kuznetsov, Uniswap v3 code, and add original Uniswap v3 pool code from official GitHub Uniswap v3. So I mix this code, this repository with official Uniswap v3 pool code. So we have here official logic of Uniswap v3, and in factory I delete requirement for fee, so we can create our pool without fee, and we have stick spacing equals to 1 just for our test. So we have our old example. We have our old pool where we have 5000 token 1 and 1 Ethereum token 0. Currently price we have 5000, P upper we have 5500, and P lower we have 4545. It's our old example. We can see how we create pool with these params here. After test, after creation pool, we can see balances of reserves in this pool. So it will be almost 5000 without 3-way, and almost 1 Ethereum. Almost. Then we can read information about currently price and current tick. Current price we have this value, square root price multiplied by 2 in power 96. We have this square root price currently value, and current tick in slot 0 we have 85,176. For our help we use some our another contracts, and for example, we can use this price for retrieve tick number. Yeah, it's correct. Okay. Okay, so what happens when we want sell to Ethereum? We have UniswapV3 Swap function. And the 5 arguments which are received this function. Accept this function. Address recipient, bool041, amount specified, square root price limit, and bytes call data. Today we use these 3 arguments. So recipient, it's obviously our address of user who will sell Ethereum. Data, in this function we not used. I don't see usage of this information. It's for callback function. We don't touch this. You just go to save transfer and it will be enough for this day. So what happened when you want sell to Ethereum? Now let's move and see in code what happens. We have requirement amount specified, so how many assets we want sell. For our example, it will be 2 Ethereum. You remember that 0 for 1 it's for destination of movement price. So if price move from 0 to 1, it's true. If user want sell, it's mean if user put in pool token 0, so quantity of token 0 will increase, price will decrease, because we have price of token 0 in terms of token 1. So if in our case 0 for 1 will be true, if we sell token 1, it will be false. It can be false if we go to if we increase price. So it will be true often in our case. Next, square root price limit. It's a limit which user can define, and price will not go lower or upper from this limit. So in our case, price limit must be under price currently, underpriced currently. So in test, when we swap we use square root price from 4000. Further we change this and look to behavior of our UniswapV3 pool, how it work if we change this price limit. For example, it will be square root, but you must understand that this is a function and we have something like this. Yeah, from this 4000 we convert this value and receive something like square root rise and multiply by 2 in power 96. Data we don't touch this, yeah, we just omit it. Next, amount specified not be equal to 0. Yeah, it's not a problem. Next we create structure and with name slot 0 start and assign information to this structure from slot 0. Next, it our reentrance guard, some modifier to lock unlocked. So we go to this function and we can't do this twice before slot 0 will not unlocked. Next, we just check our square root price limit. Yeah, if we move to right side, square root price limit must be under P currently and more than tick mass minimum square root ratio. Just check that user define correctly square root price limit here. Yeah, next our reentrance guard. Here we create cache info and information for fee. In our case we don't touch fee, we don't touch logic for Oracle observation and another logics. We just move to swap. So from cache we must remember liquidity start. Yeah, so cache liquidity start will assign to this variable info from our liquidity. In our case, liquidity will be here. It's our liquidity. The fields are not interesting for us. It's not a question for this video. Move next, move further. Exact input. So in our case, we know that we want sell 2 Ethereum. 2. So amount specified will be more than 0, so exact input will be true. Next, we create swap state function, not function, structure. What for this structure? It's just like new bucket. So we go to our swap and we create bucket and say that we want swap to Ethereum. It's our state bucket. And next we will create one more bucket. It will be state. It will be step. So we will modify our state bucket and every step. So when price go to ticks, every tick, you can imagine something like this. So every step we modify our bucket state, and then when we do all calculation with our amounts and state variables, we use this state and complete swap full or partially, but in the end we use state bucket, state structure. Okay, so here our state bucket, state structure. What we have here, how many tokens, amount in, something like this. So how many tokens user spent, how many tokens we calculate and can give to him, currently square root price, current tick, so we can see assign to this information info from slot 0. We don't touch fee, and liquidity. Remember, cash liquidity start, it's our start liquidity. Nice. And we move to while. So in while we have two requirements. First, state amount specified not equal to 0. It means that if we want swap, for example, 0.1 Ethereum, we store this information in amount specified remaining, and during swap we drain this value, and when it's equal to 0, we stop our iteration in while. It easy way. It's obviously obvious case, but we in our case we don't go to this requirement. We won't sell 2 Ethereum when we have assets in pool only 5,000 USDC or token 1 and 1 Ethereum or token 0. So we not drain our 2 Ethereum, our amount specified remaining, and it will be not equal to 0. We cannot go from while use this check. We never reach this. Next check. State square root price x96 doesn't equal to square root price limit. So it is a second check, and it's not obvious, but it is. We use this check for go from escape from while, and further I show you how it works. So yeah, you understand that we have state square root price. We modify this square root price every step, and if user if he define limit price, so we reach this limit, we stop and go from while. Okay, next we create step structure, and we store all information about steps. It's my code, it's not official, it's just for display how many times we go to iteration in while, and that's it. Iterations increment. Next line. Step square root price start. You define this information and assign value of state. Yeah. So we create a bucket and store this price. For example, it will be Y, and here price Y. We just store this information in step 2. It's start information from beginning. Next, it's crucial function. We have tickBitmap function from library tickBitmap. Next, initialize tick within one word. You must understand how work this function. How work tickBitmap. In my videos I have movie about tickBitmap, but in fast way I try explain how it works. So we have words, store ticks in words, and every word store 256 ticks, and this is mapping. Key for this mapping is first part of tick. So we have something like this. So first some part of this tick will be key for this word, and some part of tick will be index. Better watch movie if you don't understand how work tickBitmap. Okay, so we have function, we have current tick. It's not initialized. Yeah, must understand, when we add liquidity to pool, we initialized only upper and lower tick, only upper and lower. Here we can see which ticks are initialized. Initialized only 84,222 and 86,129. Only these ticks are initialized. They are not in one words. So for example, this word are end, start next word, and something here we have one. It means these tick are initialized. Current tick we have 85 85,000 where it is 85,176. It's our current tick. So how work tick initialize tick within one word? We use LTE. It's our 0 for 1. We remember that we have true. So we need move invert to right, because ticks are stored like bits from right to left, invert. So if we have our current tick here, we here from start of swap, we move to right and looking for initialized tick. Initialized tick must index of this tick must be 1. But we know that next initialized tick in our case will be 84,222. So in this word it will be no initialized tick. If word where we currently start from swap, if this word doesn't contain initialized tick, this function will return last tick of this word. This function. For display this, I add some functions in pool directly in code of UniswapV3 pool, and this function we can invoke it from our test and see what values return tick bitmap next initialized tick within one word. Let's give some time for compiling, and we must for our example take our current tick. This one. And execute this code again. So we need here, we need this information in logs tick next. This info goes after square root price next. So we can see next tick, initialized tick. No, word doesn't contain initialized tick, so result of execution this function will tick 84,992. If we go to our help contracts, here position, yeah, so we can see that this tick has position in word 0, its last tick in right side it's here, and this word 332. This function returns to us this value. Here. So we have here first iteration. We invoke this function with these arguments and receive this value as tick next, and store this information inside our step bucket. Yeah, you get it? So what is step? What is the height of these steps? Height of these steps will be O 256 ticks, or it will step to nearest initialized tick. In our case, we have several words without any initialized tick before we reach our lowest boundary, this tick. So we have several iterations where we have as results of this function every most right not initialized tick of words. So result of this function in first iteration will be this tick and false, because our tick not initialized this tick, and this tick it's just check, it's not interesting. And next we take this step tick next and use it as argument in this function get square root ratio tick. So we retrieve price for this tick and store in square root price next. So we always what we do, we retrieve tick and price for this tick. Every step we have tick and again price. So price next will be price for tick next, and we store this information in step. Let's move to test, and we must give correct information to our code. So this is another function, and which I add to UniswapV3 pool directly. So we have get next tick function, and similar function for retrieve price for current tick. And remember that in our case tick spacing is 1. It's very crucial because all info will change if we change tick spacing, but it's not for video today. I hope I will record another video about tick spacing and values in contract and function which we receive after add and increase it. Okay, this function gets square root ratio at tick in our UniswapV3 pool. We invoke it from test directly, and we send the current price and current tick. And we can see after execute this code we can see square root price next and use it and remember. So next price for next tick will be this value 594. It's last yeah 594. This value will be result of this function in first iteration and while. So here we have this info. Next we move to function compute swap step. So this function directly calculate square root price, how much we must take from user in one step, how much we can give to user in one step, and fee we just omitted. So go to this swap mass and see how it works. How many arcs we send to this function. We send state square root price. State it's our current price for first iteration. Next we have 0 for 1 true, so we our price next we just send as second argument our step square root price next, because we do not reach limit yet. Our limit in our example, yeah, it's price from 4,000, but price from 4,000 it's not equal to this value. So for first iteration we send this information as second argument. State liquidity, it's obvious our liquidity. Amount specified remaining. First iteration it will be 2 Ethereum. Fee we do not touch. So here function compute swap step. What happened here? Here we calculate how much we can take and give from and to user. We have 0 for 1 true because our current price more than target. We have exact in true because amount remaining more than 0, and we execute this piece of code. Here we just subtract fee and go to calculation amount in. How much assets we can take from user in this particular step. 0 for 1 true, so we execute this part of code. We have library mass and calculate amount 0 delta. Further I show how it works and show you how it works in step. And by the way, here you can see result of this first step here. Okay, we calculate amount in. And next we have, for example, about 2 Ethereum and in amount remaining less fee, and 2 Ethereum more than amount in. It will always true because we want sell more Ethereum than pool can accept. So we always define assign to price next, price target. You get it what we do. As target in compute swap step, we send price for next tick, initialized or tick in other word. And when we do not reach our price, our value, we just assign to next price, target price, and return it. And then when we return this from compute swap step, we assign this information to state. You see, this argument we modify state square root price in this case. One more time. We do not reach value. We want more than we calculate amount in. We define price target, price for next tick, to this value, square root price next, and return it as first argument. And here we modify state square root price. So in next iteration, state square root price will be below our current, and next and next, and etc, etc. Okay, return here. So square root price next will be this value 594. We don't go here, and we don't go here because we do not reach else. Max will be true because we assign this, we do this assignment. So next will be equal target. We have true in max, we have true in 0 for 1, so we have go here, and amount in we calculate, we just return value what we calculate before, because we have true in max, true in exact in, and we return amount in, which we calculate here, and we return it in our first step. So in first step, user must give to pool 0.2 Ethereum, not 0.2, just 0.19. This value user must give to pool in first iteration. For this value he will receive 983 tokens 1 or USDC or whatever. This is amounts from first step. This is amounts. We can see calculation of these amounts in additional function in UniswapV3 pool code, which I add only for display information, and we can invoke them and see amounts. So in logs you can see amount out and amount in first step. So here $983 or USDC or token 1 and 0.19 Ethereum. So here we just return amount in. Amount out we have max true, but exact in we have true 2, but we have invert this, we must invert this true and receive false, and all check will be false, and our calculation amount out here in this line. So we do this calculation and return amount out and amount in from one step. This fee, we do not touch them. Do not touch them. Okay, so it was calculation for first step. First step. So this function return to us next value. Amount in this is first iteration. This price in state, amount in, and amount out this value. Let's move further and use this information. Exact input we have true, so we must modify amount specify remaining. So we must modify our bucket, this bucket. So we calculate in step bucket how much we can give and take, and we must subtract it. So we have in bucket 2 Ethereum. So we subtract only this value from it and receive about 1.8 in state amount specify remaining. State amount calculated, it's how much we can send to user assets of token 1 in our case, in our swap. So for default from beginning it will be 0, and we have 983 of token 1, so it will be negative 983 in first iteration. Not go to else. And we don't touch fee. Yeah, don't say about fee. yeah, fee we do not touch here. So next we have state square root price modified. So here in state will be this value 594 at last digits, and this state square root price will be equal to price next step square root price next, where we calculate this information. We calculate this information here. We calculate this information, send to compute swap step, retrieve this value from compute swap step, modify state square root price x96 and compare here, and compare, and receive obviously true. Okay. Next, our tick not initialized. We have false, because tick in our word not initialized. It not has additional liquidity. So we have false here. We speak about this tick, and we skip this part of code. Next, what we must do, we must modify tick and look very look at this modification. So state tick will be tick next, but -1. What this is mean? This is mean that next state tick, yeah, we can -1, and you can see we jump to another word. We jump to another word in tick bitmap mapping. So next tick in state will be 84,991, and that's it. So next we just jump to from word to word to word, because they all don't has any initialized ticks. So we modify state tick and not go here yet. And we must do this again and again. How many times? It's quite a lot, because what happened next? So we just modify tick, find most right tick in word, because we do not have initialized tick. Do subtracting for 1, jump to another word, and repeat these all actions again. So we have here 6 iterations, 5 with some values. So we jump from initial tick, it's our initial current price, it's information for first iteration, next tick, next price, next value, and you can see how it works. When we reach to our lowest boundary, our lowest tick, which we define in params our pool, we don't get any value, anything. And I show you if and you can see that for drain almost 5,000 USDC from pool, user must pay this amount of Ethereum. And I propose to you, and average price of this purchase will be 4,770, which are quite logic, because if you divide this price range by half, it something like this, and it's logical. Yeah. Let's move to code and see what happened in last iteration. Where we have initialized tick. So here this tick not initialized, this two, we have only this tick initialized. So what we have in last iteration, in our while, we stuck in while still, we do not go anywhere, we just move around in while. So state tick will be 84,223. Tick next will be our last tick, and it will be initialized. Initialized will be true. Next, we retrieve this price from this tick. Yeah, and we can get tick from price. Something here I have Okay. Okay, for this tick will be price, this price. It will be result of this function. Next, we send this information to compute swap step. So here this info. Yeah, so next it will be target, it will be our current price for tick 84,993. It's price for this tick, and it is for lowest our tick price. Liquidity doesn't change during price until we reach initialized tick and drain all assets. And further you can see how it modified and changed. So amount remaining, we have this value. It's not important. It always will be more than 0. For last iteration we can take from user only this value of Ethereum token 0, and we have true here. We modify square root price next. Square root price next. Last iteration before initialized tick also true here, and we just retrieve amounts as previous iterations. And here we store this info. So last iteration we return instead this price, step amount in this value, here we receive, and move further. And amount specified remaining in last iteration we have this amount, so it's about 0.95, yeah, and last iteration it will be minus almost 5,000 of token 1 or USDC. Fee don't touch fee. State liquidity, it's again about fee, yeah, and we have true here again, and here we have this step initialized true. We reach our lowest tick, and we must execute this part of code. It's my code, it's not official UniswapV3. Don't mention for this your attention. And this we work with Oracle logic, and what we need here, it's we do not modify nothing. What we need, cache liquidity, we just send, we not modify here nothing. So next very important thing in its liquidity net. Liquidity net, it's a result of tick cross function. What this function do? So we have this tick 84 222, it's the lowest tick, so we send this tick to this function, but it's we must understand this is function like library, so it's like method for this mapping. So we use this function, this method, for this mapping, for mapping ticks. Mapping ticks contain information about tick and contain structure tick info. In this structure tick info we have liquidity information, liquidity net. So if we invoke function from our test, you see here I ask our pool what information stored in ticks mapping with key our lowest tick, and I retrieve only liquidity net information, and I think we can see this in logs, why it's 0 here. I don't know, maybe I change something, here. But in right case, in liquidity net you must see this value in tick info structure. So when we go to ticks mapping and execute method cross from ticks library, this method. We use self-mapping and tick lowest hour tick. And what we do, we define liquidity delta and assign information from liquidity net to liquidity delta and return this information. So in liquidity net will be our liquidity, this value, because we reach to our lowest tick, and that's it. We drain all, we use all liquidity, so it must be modified and subtract. So if 0 for 1 it's true, in our case it's true, we just use negative for liquidity net minus, and after this you do function add, and this is obviously just subtracting from our state liquidity, and we subtract liquidity net and receive 0. So our state liquidity in this iteration and other further iteration will be 0. It will be 0. And next step, we again modify our state tick. We remember that tick next, it's our lowest tick. So our lowest tick, and we must do subtraction and minus 1. So we have this tick. In case of mapping, so tick bitmap mapping, so imagine our tick, lowest tick, and we just do minus 1, and we jump here and repeat again and repeat again and again and again this combination. How much we do all, we drain all liquidity, but we don't know, maybe in some other way, in some other diapason range of maybe something here, we have liquidity from 3k to 2k, and user accept it. He just define limit price for 1k. It's normal for him buy asset for this price, and we must go further until we reach limit which define user. In case if user not define limit price, if he define 0, we must go to our minimal tick. how much iterations of swap will be. How much? So I can show you this now. We have our swap, our pool, and we have swap. We have our swap to Ethereum and params, and we have limit at 4,000. We have limit at 4,000. So next we just go to pool and read information about iterations. Remember that we increment iterations 1, when we go to while. So if we go to while, we always increment iterations 1. When we go to initialized tick, when we go to part of this code, we increment iterations 2. And if we go to this part of code, we increment iterations 3. So we execute this code, and I want show you gas report here. What we see in logs? We see a start pool. We can see pool user in tokens 0. It's our Ethereum. We mint this Ethereum for our swap, and we can see that user has 2 Ethereum and something fractional part. Next, square root price 96 before swap. Next we have liquidity before swap. You can mention that liquidity after swap is 0. Square root price after swap are changed, and user receive this value amount out, and reserve of token 1 in pool are 2 way of token 1 or USDC. And we can see increased user balance after swap, and we still see balance remained of token 0 in the user balance and token 0, which are remained on his balance. And we can see number 10. So in our case, swap single cost 176,000 gas, because we define square root price 4,000. What happened when we define this square root price 3,000 for 3,000? Obviously we must jump more and more and spend more gas. So we have already 22 jumps, 22 iterations of while. So our swap function cost 286,000 of gas. And what we can do if we just define square root price limit for 0. In this function swap single we just must swap, yeah, and here you can see that if I define square root price limit as 0, so we must jump to our minimальный tick. So how much jumps we have in this case? Yeah, we have 3,800 jumps, and we spent almost 36 million gas for our swap. It's quite a lot. It's in common way size of Ethereum block are 30 millions, and it can increase, but in common way it's only 30 millions. So we spent 36 millions. So we can escape from this while only if we reach to our amount for swap, or we just reach to limit. Only these two variants can give us possibility escape from while. That's it. So yeah, and several words about this part of code. We go to this part of code in the end of our iteration. Yeah, so when we reach to limit, or when we reach to our minimum tick, we don't have we have this we have true here. So state square root price x96 will be modified to price next, or will be modified to limit here. In compute swap step, we do not send at last iterations step price next anymore. We send here limit. On last iteration, when we reach to our limit, and return this limit and modify state square root price x96. So here state square root price will be limit price, and limit price will be not equal to step price, which we calculate from this line of code. So in the end of swap, we go to this part of code and modify stake tick. We have limit price. We get tick from this price and assign this tick to state. So in this case, if we for example set that we have 4,000 price, it's our limit. It will be tick 82,944. So this tick will be assigned to state tick variable. And that's it. We escape from while. We escape from while and ready move further in code. Our state tick doesn't equal to slot 0 start. We do some logic in Oracle with observation. And next we modify our slot 0. It's directly assigned to current square root price, state square root price. Directly assigned to slot 0 tick, state tick. We change slot 0, we change it, we store information from state to slot 0. True. If our swap was within one tick, if we have enough liquidity and we just do swap within tick, we just not move any tick, so we anyway must modify price from state to slot 0, and here we modify our liquidity. You remember that cash liquidity start is liquidity from start. We put this liquidity into cash here, cash liquidity start, yeah, and we do not modify it nowhere. So here will be our liquidity. Liquidity this liquidity in cash liquidity, and this liquidity will be not equal to state liquidity. Yeah, state liquidity is 0 because we modify it here on this line of code. So next we modify liquidity, we assign it to 0. Last iteration. Yeah, and next emit fee, and here we just reach 2 transfers. So we calculate all information what we need. We need this part, it's 0 for 1 true, exact input true, and we must go here and calculate. So we must specify our, it's 2 Ethereum minus state amount specified remaining 2 minus this value. So we must take from user 1.05 Ethereum and give him state amount calculated almost 5,000 USDC. Amount 0, amount 1, we have true, and it's just callback functions for our router or manager contract, where what we take assets from user and give him his buying assets. That's it, and we have locked slot 0. UniswapV3 very difficult project, and it's not enough this book for understand all information about swaps, because I don't see this information about steps. I don't see information about how many steps can be, because official code is much better and give clear information about how project work, how swap work, and what happens with variables, assets. Okay, I hope you enjoyed this video and it was useful for you. Thanks for your attention.